So today we're going to talk about simulation. And simulation is something that we can do in order to actually try to figure out what the probability of getting a certain number or outcome looks like. So a lot of times we don't want to actually go through and attempt to figure out what the probability is by hand. We instead want to simulate it. Especially computer simulations can really be helpful if you know how to design and set them up. That way you're not having to actually do the work behind it. So I'm going to show you a simulation here. This is the simulation of tossing a coin 16 times. So going into that problem, if I asked you, how many would you expect me to get heads? Okay, this is the probability of heads you can see here. How many of these would you expect to turn out to be heads? You guys would probably tell me, well, about half of them, so 8 of them. We know that there's variation here. So in this one, if you look at the bar graph, and I'm going to zoom in a little bit here. Let me see if I can. Yep. I'm going to zoom in. You can see these other values here, like the 10. It asks, what does the 10 mean? Well, that 10 means that when you toss the coin 16 times, this is how many, well, in this one, the probability of getting 10 heads goes down. It's under 15%. Okay, so that's the concept here. Under 15% of the different values that we got would be a 10. And you can see it gets more and more infrequent. This would be pretty rare, right? To get 16 heads or get no heads when you're tossing a coin. That would be extremely, extremely rare. So that's what you're seeing there. I'm going to talk about this as well. We know that the probability of tossing a fair coin is 50%. There are 2 different outcomes, heads and tails, and if it is fair, then it's a 50% outcome. This right here is recording or tracking the probabilities on each one, and you guys can see what's happening in these is it's getting closer and closer and closer and closer to that 50% as you add the different values. For example, what you're looking at here is after one toss, it looks like they got a heads in this case, okay? 100% of your tosses so far with your 16, 100% of them are heads. Then when it drops after your second time, it drops to 50%. What that means is that your next toss must have been a tails. So now your proportion of heads is 50%. Then you can see it wavers. They must have got a heads, then a tails to bring it back down, another tails. But you can see this heads and tails balancing back and forth. And as you guys can see, it's getting smaller and smaller and smaller because it's getting closer to that probability of 50%. I think you guys probably would understand this in real life as well. If I toss a coin 10 times, it could happen that in those 10 times I get all 10 heads, or 80% of them will be heads. It seems probable. But if I toss a coin 1,000 times, it's pretty unlikely that all 1,000 of my tosses would be heads, right? Like it seems like, and it's true, that if I toss it very many times, I'm going to get closer and closer and closer to that true probability. That's the idea of simulation. We want to simulate very many times. So in your simulation, I'm going to actually click on notes for a second so you guys can see. We are going to simulate doing a couple different things. We will be, first of all, stating any kind of assumptions that are made. When I say assumptions, I'm going to go in, I actually don't state the problem anymore. I just go straight to the assumptions. And let me talk about what that means. I am going to state my assumptions numerically by saying, okay, my girl happens 50% of the time, my boy happens 50% of the time when having children. Those are my assumptions. I have to assume that that is true. Okay, and if you guys know anything about nature, boys are slightly more prevalent than girls. So that's why it's important to say, okay, I'm making the assumption in this case that it's a 50-50 chance. The next thing you're going to do is actually assign the digits. So I'm going to assign 5 numbers to girls and 5 numbers to boys before I go into my table. So I'm going to do 0, 1, 2, 3, 4 for girl and 5, 6, 7, 8, 9 for boy. I want to make it clear. I could have instead done a 1 for girl 2 for boy. Okay, and assign just a single number. I could have done that. That would have been actually really easy for me to do. But here's the problem. When you go to your table and you have this table of random digits at line 130, 8 of the numbers would not work. 0 wouldn't work, and 3, 4, 5, 6, 7, 8, 9. So you'd only be going across and looking for 0 or 1s and 2s for the boys and girls, or 0s and 1s, whatever you want to make them. But you're only going to be picking out 2 numbers and then omitting a whole bunch of numbers. If you choose to do it this way and do 0 through 4 and then 5 through 9, then every single number that you get will represent one of them in your group, either a boy or a girl. So it's kind of up to preference on that one, and I'm fine with you using either one. After that, you're going to simulate. So in this case, you can see I actually simulated. This is a couple who plans to have children until they have a girl. So if their first child is a girl, they're done. They're done having children. Okay, that's what you see in this simulation. Or until they have 4 children, meaning like I'm willing to have 4 children. I'm going to stop at 4 though if I don't have my girl yet. If my second one's a girl, I stop. So you can see my simulation here. I went to table B, line 130, and grabbed every single number. So 6 was a boy, 9 is a boy, 0 is a girl, and they stopped having children. They stopped. So basically you're stopping every time there's a girl. So in this case, in this simulation, they had 2. In this simulation, they had 2 kids. In this simulation, they had 2. In this simulation, they had all 4 kids, but at least they got their girl at the end. And you can see in this simulation right here, they had 4 boys. They actually never got their girl, which happened for me 1 in 14 trials. That only happened 1 time in 14 trials. So the probability of this couple, if I'm doing it that way, the probability of this couple having a girl is pretty good. It's 13 divided by 14 in this simulation. They have like a 93% chance of having a girl if they're willing to have 4 children. That's the concept behind this one. So stating your conclusion, I would say exactly that. The likelihood that they will get their girl is a 93% chance based on my simulation. 13 out of 14 times they would get a girl. Okay, so talking one more time about assigning probabilities, it's pretty easy when you have a 50-50 shot. You can actually just even use 2 numbers, or you can use it broken down like this. But when you have a non-50-50 shot, let's say that you have somebody who's really good at shooting basketballs and their free throw rate is 75%. 75%. I would instead use like 4 different numbers instead, like 1, 2, maybe I use just 1, 2, 3, 4. A 75% chance would mean that she would make the basket 1, 2, and 3, and she would miss it on a 4. So that's how you would do like a 75%. If it was something odd or off the wall, like a 22% chance, I would use the numbers 0, 0 through 21. Okay, that's 22 numbers because 0, 0 counts as a number. So 0, 0 through 21, and then 22 through 99 is how I would break that percentage down. And then every number, like the 2-digit chunks that I would get, would be a solution. Simulation, we continue tomorrow on example 11 in your homework on tomorrow's assignment. You will be doing a simulation exactly like what I was just talking about. If you want to see my work for that and see how I did that simulation, pop over to the homework help video on tomorrow's lesson and I'll make sure to go over that.